Okay, so the other thing we're talking about today are composite functions and the domain. So a composite function is a function within a function, and the way that you pronounce this, okay, all three of these mean the exact same thing. This is f of g of x, this is f of g of x, this is f of g of x. I know that some of these look like fog. Okay, the way that you pronounce this is f of g of x. Okay, so we're going to say that correctly. F of g of x. And then what this means is, this means we substitute g of x into f of x for x. And I know that's a lot of x's in there. So we're going to be substituting g of x into f of x in place of the variable x. So what we're going to do is, instead of substituting in numbers, we're going to be substituting in expressions. Okay? Now, we also are going to talk about the domain. So with the domain, it's easier to look for restrictions. So you want to think, what values can I not plug in for x? So we've already talked about some of these today. We said the denominator can't be 0. So what you want to watch out for are fractions. Because whenever you have a fraction, that means the denominator can't be 0. The other two are related. Do you guys remember? Because you did say them earlier. Yeah, the square root. So there's going to be square roots, and then this really happens for any even root. Okay, so for square roots and any even root. Okay, and for those two things, you can't take, we'll just put the symbol. So you can't do the square root of a negative. Okay, you can't do the square root of a negative. So when we set this up for the domain, have I told you yet what the value under the radical is called? It's called the radicand. Whatever's underneath the radical has to be greater than or equal to 0. So it can't be negative, which means it has to be positive, or it has to be 0. Okay, so when we get there, we'll be taking whatever's underneath the radical and setting that greater than or equal to 0. Okay, so the first thing we're going to do is we're just going to highlight all of our beautiful functions here. Actually, let's just start with the first two. And we'll do f of g of x. So f of x is x squared minus 1. G of x is x over 1 minus x. And it says to state the domain of each. Anytime you find the domain, we're going to write that in set builder notation, which is simpler of the two, especially in this case. Okay? All right, so for the first one, I'm going to help you set it up. What we're going to end up doing is we're going to plug in g of x into f of x. So whatever one is on the outside, we're going to create a shell, okay? So f of x, let's look at that function. It's x squared minus 1. Okay, so for x squared minus 1, instead of x, I want you to write parentheses squared minus 1. Okay, so f of x, so write this down with me. F of x is x squared minus 1, so I want you to put parentheses squared minus 1. So instead of x, we're going to replace that with g of x. Okay, so we're going to plug g of x in for x. What is g of x? Okay, so that's what we're going to substitute in here. Okay, so this is what you substitute for x. Okay, so you're just going to plug it in and you're going to simplify. All right, so when you simplify, if you have a fraction and it's squared, you just square the top, which is x squared, and then you square the bottom. And then anytime you have something to an exponent, you do have to make sure that you simplify that out. So remember, you don't distribute, you FOIL. So let's FOIL this on the side. So 1 times 1 is 1. Negative 1x and negative 1x. Negative 2x. Negative x times negative x. X squared. So now we can write this in standard form. So it's x squared over x squared minus 2x. It's a positive 1. And then we still have the minus 1 on the outside. This is your final answer. Now some of you might be thinking, well, why can't I cancel these two out? The reason why you can't cancel out the x squared is because this is a quantity with that's x squared minus 2x plus 1. So you would have to simplify this first before you could divide. Okay, so you can't divide if you have anything added or subtracted. Okay, now we're going to look for restrictions. Do we have a fraction? Yes, so if you have a fraction, your domain has to include that the denominator cannot be 0. So all we're going to do is we're going to set our denominator equal to 0 and solve. So x squared minus 2x plus 1 equals 0. And this is a quadratic, so you can either factor to solve, you can use the quadratic formula. I would factor because it's very easily factored. Okay, so what multiplies to 1 but adds to negative 2? Yep. And this is a multiplicity, so if you have x minus 1 equals 0, no matter what you do, x can't be 1. So this is how we're going to write it in set builder notation. The domain is x such that x cannot be 1. Okay, we're going to go to C.
Why is he hard?
No, we're just shaking things up today. All right, so for C, okay, I'm going to help you set this up again. So again, on the outside it's f. So what we're going to do is we're going to rewrite f of x, but without the x. And instead of x, we write parentheses. So if it's x squared minus 1, okay, then you're going to put this here. All right, and then will you fill that in for me? Okay, so then, Joey, what did you put on the inside there? This time it's h of x, right? Okay, so what is h of x? Yep, so h of x is, and maybe we should highlight this here, okay? Okay, so your 3x minus 4. Oops, sorry. I just plugged it in. Okay, now could we simplify that part? So 3x minus 4 times 3x minus 4. Okay, so I want you to FOIL it, simplify, and then I want you to think about the restrictions, if there are any. So your pens and pencils should be moving at this point. I'm not sure what you're asking me. All right, so you foiled this, and then Zach, what'd you get when you foiled this?
9x squared minus 24x plus.
Yeah, and then you still have the minus 1 on the end, so our next step is just to combine your like terms. So 9x squared minus 24x plus 15. Okay, and then we're just going to look at the restrictions. Do you have any fractions? No. Do you have any roots? No. So then guess what your domain is? All real numbers. So do you guys remember how to write that in set builder notation? The element. Yep. So all real numbers x such that, all numbers x such that x is an element in the real number set. Okay, so that's going to be your all real numbers. Okay, great. All right, do you guys want to try the setup for E without me?
I guess I'll try it.
Okay, let's try.
3 times x squared minus 1 minus 4.
Yep, so your h of x is 3x minus 4. Yep, and then you're going to plug in your f of x, which is x squared minus 1. Yay, sounds like we had a successful substitution here. Okay, so now we have to simplify. So we're going to distribute. So 3x squared minus 3 minus 4. Yeah. And what's our domain? Great. All right. Let's try G. Okay, so this one is going to be with your k of x, and k of x is the square root of x, right? All right, so if it's the square root of x, okay, you're just going to do the square root. You don't have to put parentheses in it if it's just root x, because you're going to plug in the 3x minus 4. Now, this can be tricky the first time because we're so trained for those perfect squares that we want to simplify that, but we can't. You cannot simplify if you have the minus there, okay? It's, do you guys remember doing Pythagorean theorem a lot last year? Yeah. So a common thing that you had to do is like the square root of 16 plus 9, right? Okay, so let me prove to you why this doesn't work. Because the square root of 16, if I were to break these up and simplify, 4 plus 3 would be 7, right? But what's 16 plus 9? 25. And what's the square root of 25? Right. So this is correct. This is not allowed. Okay, so you cannot split those up. So you know what that means? This is your answer. Okay, so you cannot simplify that.
We gotta do a domain.
And that's right, we have to do our domain. Okay, so with the domain, obviously we have a radical. So whenever you have a radical, you have to take what's underneath the radical, called the radicand, and set that greater than or equal to 0. So you are just solving a two-step inequality, which we have already done this year. Okay? So you would add over 4, divide both sides by 3, and x would be greater than or equal to 4/3. Now, to put that in your domain, all you say is x such that x is greater than or equal to 4/3. Put your fancy brackets on. That's your domain. Okay, so I want you to do H next, and then I want you to try F, okay? So do H first. Really, we're going to work our way back up. So when you substitute this in, right, H is 3x minus 4. So when you plug in the k of x, which is just root x, when you simplify this, you can't multiply something that's outside of a radical by something that's inside. So the way that you write that is 3 root x minus 4, and that's your final answer. Okay, and then again, you take your radicand, you set that greater than or equal to 0, but the only thing under the radical is what? X. So it's just x is greater than or equal to 0, so you really don't even have something to solve for. It's just going to be x is greater than or equal to 0. Okay, so let's look at F. For F, G is the value that's on the outside. That's our function. G's a little different because if you look at G, how many x's are there? Yep, so now we need 2 parentheses. So on the top it's x. On the bottom it's 1 minus x. Okay, now we can plug it in and now you can simplify. Okay, so plug in your h of x. Okay, so there's nothing to simplify on the top. You can just keep that. On the bottom, what do we have to do? Distribute the negative. So negative 3x plus 4. And then what are my like terms? 1 and 4. So on a question like this, I'll accept 2 answers. You can leave it as 5 minus 3x. This is kind of common when the first term is negative. You can leave your answer like this, or you can also write the denominator in standard form. You could also have negative 3x plus 5. So either one of those are correct. Okay? And then do we have a fraction? Okay, so then we have to take that denominator, set it equal to 0, to find what it can't equal. So if you use the 5 minus 3x, when you're solving that, I would actually add the 3x over to both sides, so I don't have to deal with the negative, right? So if I add that over, I have 5 equals 3x, divide by 3, so x cannot be 5/3. Okay, so for the domain, it would just be x such that x cannot be 5/3. Okay, and then you guys are going to try D, and some of you are going to be able to simplify that without me. Just keep in mind, when you are multiplying a fraction by a whole number, think about what gets multiplied together. Okay, so I'm going to give you a few seconds to set that up. And then think about what you do when you're multiplying a fraction by a whole number. That's where I would do, yep. Okay, so you have 3x minus 4, and then x over 1 minus x went inside here. When you're multiplying this by 3, a common thing to do with the whole number is to do what? Yep, put the 1 over it, right? Because that was your reminder that the whole number gets multiplied by the top only. So it's 3 times x, which is 3x. On the bottom, it's 1 minus x minus 4. Nothing else to simplify, so you can keep it just like this. And then can you guys do the domain? And then again, I would just add the x over. So x can't be 1. So we would say x such that x cannot be 1. And you can look and see, if you plugged in 1, 1 minus 1, wouldn't that be 0? And that's where the problem would be. Okay, let's try this one more. You guys are doing really well. And then see if you can simplify it and do the domain. All right, let's check our setup. And then what would we do from here? Distribute the negative, great. So a negative times a negative is a positive. Now be careful here. This is a positive 1 and a positive 1. So if I have a positive 1 and a positive 1, that's going to be 2. So you can either write this as 2 minus x squared. You could leave it like that. You do not have to factor this, okay, because you aren't going to be canceling anything out for this, because x squared isn't going to, the 2 minus x squared isn't going to factor. Okay, so you can have one of these two, but now we have to set the denominator equal to 0 so that we can solve. Okay, so if the denominator can't be 0, and you have 2 minus x squared, if you add over x squared, how do you get x by itself? Yep, and when you take the square root, what do we need in front? Great. So then when you're writing this as part of your domain is just going to be x such that x cannot be plus or minus root 2. Okay?